Hello, hello. Just getting everything going. As usual, I just restarted my computer because I don't trust it. And for some reason, cat cam is not adjusting. Cat cam is not happy. But Spook is there. It's like it adjusted to my hand. But it's not. I don't know what the deal is. Hey, sorry for the pre-roll ad. I usually try to turn monetization off. Yeah, I usually try to turn it off, but maybe they don't let me. Hi, Dave. Hi, Hugo. Hi, Chloe. Hi, Bruce. Hi, David. Twitch and YouTube are live. Thank you so much. Hi, Juan. Unfortunately, Discord on Arch does this really weird thing where if there's a for Discord, if there's an update and you start it up, it says, hey, how do you want to update? And it says Debian package, tar.gz, or I'll do it on my own. But if you hit I'll do it on my own, it just doesn't start. So that's kind of bonkers. So that's why we don't have Discord on the screen right now. I do have Discord open though, so I can see the chat. It's just I have it in the browser because that's silly. Oh, and I gotta share out the notes doc, which I do have here. So this is pretty standard for me to be getting going here. We'll start in just a bit. It does give folks time to tune in as well, which is good. Somebody asks, how do you get your products in India? I'm not sure whether we ship to India or not. Where's my tab? We can look. Yeah, the distributors page on Adafruit.com. So thank you, Hugo. We go to the desktop, and let me shrink this hidden browser down so it's actually below. Oh no. So I actually do have the clue with timecodes running. Actually, I can show you on the overhead. So I've got this going. Unfortunately, oh, and I've got this mystery box here. I'll have to turn that off. Unfortunately, I forgot to do it. I forgot to press the button when I did that. Let me squeeze that over too. Yeah, everything's a little bit shifted right now because Discord threw me off, and I restarted because the cameras weren't working. So yeah. But I did get, my goal was to get the overhead because as you can see, I've got some stuff underneath it as well. But I do have this timestamp thing, and I just missed the 4-minute mark, but I was going to hoping to do it on a minute boundary here so we could just offset them all. Okay. Sorry for the cat cam. I don't know. Like, I could plug it in and plug it back in, but I don't know. Like, maybe at some point it will decide that it's too bright. It's not like I'm trying to do manual control of it or anything. Okay. Yeah, so I was going to show that on Adafruit.com, and I'll pull it up and just, so desktop. You can do to Adafruit.com. Oh, and I thought it was distributors. And in fact, it's in my history, but maybe the page is down. There we go. Hugo asks, how was my Thanksgiving? My Thanksgiving was good. My wife made dinner, and I made chicken. I did the chicken and the apple pie, and she did like a bunch of sides, and they were all like really really good. Um, oh yeah, and I was gonna share. I have to share the notes. Sorry about that. There's the note stock. This is what we use to keep track of time codes, because the stream does go about 2 hours. So I try to put in the description time codes so you can skip around. But I'm a little discombobulated by... Oh. Here's the 6-minute mark. Okay, 6 minutes. Perfect. So I got that. So that what I did is I just pressed a button. So this time here on the clue that's running my time keeping is it's 6 minutes off. But I'll try to be using that throughout the stream. Save me some typing. There was this, since I'm talking about it, I actually use Colmac. I don't use QWERTY. And so I had this issue where I was pressing it and it was doing like 2 numbers, the capital letter O, and then 2 numbers. And that's because my the code is expecting me to be using US QWERTY when I'm not. So I'd use this page here to figure out what the mapping is, so that like in the code I replace the colons with the capital P, and then I get a colon out the other end, which is neat. Okay, so yeah, going back to the question about how to get the products in India, there's distributors here. There's also a map that you could go to and look. Looks like there's engineers toys, DIY components. So there are some options, so you could take a look at those. The other thing I would say is that I know that Microdev, who's been a huge help, is also in India, and so it ships from India, so that should be doable as well. So support Microdev. They make this really teeny tiny ESP32-S2 board, which is well supported by CircuitPython. Okay, let's start housekeeping. Only 8 minutes in, which is actually not too bad. Okay, so let me... Okay, so what am I looking at? Hello, everybody. My name is Scott. I work for Adafruit on CircuitPython. Adafruit is an open source hardware and software company based out of New York City. Personally, I'm actually based in Seattle, which is on the other side of the United States. So I work remotely. This is my house. In the blown out camera up in the corner here, that's my cat. And so yeah, Adafruit has a lot of remote folks. I'm one of them. I work on CircuitPython, which is a beginner-friendly version of Python for microcontrollers. Microcontrollers are these really small, relatively simple computers they can buy for, on their own, a couple dollars, but kind of all in one thing for like $20 to maybe $100. It's kind of like the common price range for them. So what we do with CircuitPython is we make it really easy to program and iterate. I already showed an example. So the timestamp thing that I'm using is done by a community member. And the nice thing about that is that it's all running CircuitPython. So it's using CircuitPython to monitor the button and then type to the computer. So it pretends to be a keyboard. So that's what CircuitPython is. This stream here is a deep dive, which is something I do most weeks, usually on Friday at 2 p.m. Pacific, which is a chance for me to go over what I've been working on CircuitPython, kind of what's happening in the CircuitPython space. I started this stream kind of like in the pandemic and when we were doing ESP32-S2 work, which is a particular microcontroller that has native Wi-Fi and native USB, which is like kind of first of its kind. And so we've been kind of cataloging the progress of that. But I'm also like super happy to answer questions and go on tangents about things. What I mean by deep dive is that we will like get into technical topics if we get there. The stream usually goes for about 2 hours. I shoot for like 2 to 4 p.m. Pacific, so we've got time for those tangents and the questions. And yeah, so if you have them, go ahead and ask. I've answered, I think, everything that I've seen in the chat so far. And then two other things. The cat who you can't quite see in the image because it's not adjusting right is Spook. He's a cat. He's one of my cats. We have two, but the other one gets really ornery when I start talking, so she usually isn't in the picture. But Spook likes to lay in the window in the sun, and he is epileptic, which means he does have seizures from time to time. He's been doing really well, so I don't expect it to happen. But if it does, what I'll do is I'll just mute. You won't see him. I'll take like 5 to 10 minutes to make sure that he's okay, and then continue the stream. So that might happen, but is unlikely. And then lastly, next week, the stream is on Friday again. We took last week off for the U.S. holiday Thanksgiving, which is really nice, although it was a little weird not to have streamed. So excited to be here. We're going to do, I think I was looking at the schedule because Christmas is in a couple weeks, Christmas and New Year's. So I'll probably do like 2 more this year, take a week or 2 or 3 off, and then do, and then start up in the new year, I think. I've gotten really good feedback that people like this, even though like 2 hours of a video is kind of long. I won't necessarily do it forever, although I do really like doing it. So if you do like it and you want to see more, and you have topics in particular, let me know. We can keep it going. Chloe says, Spook is the same name for my cat that passed away, sadly. Sorry to hear that. That's really rough. That was definitely something I was thinking about when Spook first had his seizures of like, is he going to be able to live like this, or do we have to put him down? Luca, hi Luca's Lab from Brazil. Thanks for getting on and watching. And Johnny says we want to see more. All right. Well, I'd love to know what you want to see more of. Okay. So that is housekeeping. Let me take a time code, which are 6 minutes off. Talk about the plan. I got one goodie in the mail that I wanted to show. And then I wanted to cover all the tweaks that I was doing a lot of odds and ends on the S2. So I want to talk about those. And then I want to talk about sleep. I've actually got my power monitor set up as well. And I have a PR that seems to be working, but needs to be refined and make sure that everything else is like tidied up and working. So we have lots of sleep work to do. So I'm okay if all the other stuff doesn't go too long. But yeah, I think that's the plan. Bruce S says, I have many questions, but no answers expected. I mean, you're always welcome to ask questions. I am perfectly happy to say I don't know. I encourage that. The one thing that'll get me a little prickly is if you ask me when I'm going to do something for you. That's a little bit of a like, well, you're not paying me to do it, so. Although I do have GitHub sponsors. Bruce S, nothing's too much in the weeds. I don't think. I mean, if it has to do with CircuitPython, it's certainly not in the weeds. We'll see if Bruce wants to get a tangent here before we talk about the microbit. We'll probably end up in the ESP32-S2 weeds anyway, which is, I think, what people are here for. In looking at the I2C code, I wonder if the semaphore is incorrect. I don't see a reference to a handle. Yeah, it could totally be. So we have this like bug that's been around for a few weeks, which is like Wi-Fi plus I2C gets it hangs, I think. It doesn't crash, it hangs. David asks, where am I broadcasting from? I'm in Seattle, Washington, so in the U.S. And this is my office in my house. I work from home. And I worked from home before the pandemic as well. Um, Hugo says, I'd selfishly say keep going on the deep dives, but that's just because I like virtually hanging out. Skull and Clawbones says, first time here, I'm just trying to understand what you teach. I talk about CircuitPython. I wouldn't say that I teach it. It's kind of more like if you were to look over my shoulder and see what I was working on. If you have questions, then I'm happy to try and answer them. I think one of the things that I've done on the stream that was really successful was kind of going over the basics of different ways that you can talk between a microcontroller and a device using like I2C or SPI, things like that. But I don't want to recover too much ground as well. Yeah, so Bruce S has been looking at this I2C issue, and I haven't personally taken a look yet, although I have spent some time trying to debug other hangs that I've seen, but it wasn't while I was using I2C. Dylan says, hope you keep doing this as long as it's enjoyable for you. Always look forward to these on Thursday and Friday. Oh, thank you. Yeah. Andy Roberts says, I just received a J-Link from Adafruit. I assume that's what AF is. Was wondering if best to always use that or if there's some advantage to using native ones like STM32 Nucleo boards. Generally, I always use the J-Link because that means that the process is exactly the same. And if you want to see what my process is, let me switch to the desktop. There's a guide I wrote years ago now, and it's a bit out of date, but this debugging SAMD21 with GDB guide, I don't even know if it says when I wrote it. It may not. Yeah, last updated on October 2016. But generally, this is pretty the same to my process. This process here, even though it's just documented for the SAMD21, basically works for all the ports of CircuitPython. The one thing that doesn't really apply is like the ESP32-S2. It's a bit different because it's a different CPU core. But this approach basically applies for all of the ARM-based systems that we use. So yeah, I would recommend, and I can drop this in for MD Roberts. I would just follow this. It just the major thing that you have to change is the I don't do the open OCD instructions. I do the J-Link ones. And when you run the J-Link, but like this picture here, how I have separate power and then the J-Link, like I still do that for most things. So the only thing you have to really know is like this different device identifier. And then like everything after that is pretty much the same. And there is like a J-Link supported devices. I think it's what it is. It's not the overview, but I think the overview has the link. But basically there's a page you can find that has a list of absolutely all of them. Known devices. List of known devices. I think this is it. Yeah, so here you can see like the actual name. So if we were to look for, doesn't look like they have Atmel, but we could do like Nordic Semi because they're not going to have that many. So if you're doing it like an NRF 52840, like this is what you would put on the command line there. Okay, Javier asks, what are you using for power monitoring? I've got a Joulescope. Is what I have here. I'm not sure I would recommend it, largely because Nordic just came out with a new power monitoring thing. And in fact, I meant to order to see if it's in stock somewhere else. I ordered it from DigiKey today. I waited. I knew they had like 70 in stock. Nordic Power. So there's this power profile kit, and this is not going to be on the right page. It's like less than $100 though. So it's, whereas the Joulescope that I have is like $700 or $800. The Nordic thing is like $100. It's not quite as wide a range and stuff, but it's plenty good for all the stuff we're doing. And I'm trying to, I do want to octopart it because I actually do want to pick one up. Nordic PPK. See if that finds it. Yeah, here we go. This is what threw me off. It says 0 in stock, but can ship immediately. And like it got all the way, so don't order this. I just ordered one and it doesn't actually work. Or like it said it was back ordered after the order completed, which is a little weird. Juan says that Learn Guide is useful. I was just using it over the Thanksgiving break. Yeah, thank you. It says, if you do update it, it would be useful if you can point out that when you type connect and not enter anything, a GUI pops up with a list of all devices. That is how I usually find exact name of the MCU I'm using. Oh, I didn't know that. I've never done that. Mouser is expecting them next year. Okay. Symmetry Electronics has 50. Rutronic has 4. Yeah, I mean, I already put the DigiKey order in, so I can also just leave the order in and I'll get it when I get it, which I think is fine. I'm just kicking myself. I should have just snagged it. Okay, that is random. Skull and Clawbone says, cool, just absorbing, and thanks. Even though you don't consider yourself a teacher, you bestow knowledge. It absolutely is that role. That's true. I'm just not like a structured teacher. But yeah, it is just like a lot of deep stuff, and what you absorb is great. But you could also ask questions if there's things that you want to understand. And Ben says, I really like to know to see how you'd approach such a hang issue. I've tried a lot and somehow ended up in a hang, and now I'm hanging over a bit. Okay, let me take a time code. We should talk about this because I know you're in Europe and you probably don't want to stay up all night. So let me hit the button. Debugging the hang. So there's a couple ways. So Jeff looked at this, and Jeff has actually managed to get GDB set up. Jeff has managed to get GDB set up. And what GDB can do is it can tell you the state of all the free RTOS threads. Let me show you actually what I have. I have this branch. It's not this branch, but if I check it out, I have this TLS debugging branch, which is a branch that I've just kind of been using as a catch-all for my print debugging. So this is important. Nice. Somebody on Twitter said, thanks for the tip on the power profiler. Yeah, sorry, it's out of stock. I'm kicking myself as well. But it looks really neat. And I checked, it's actually an NRF52840 that's managing all of that. Okay, so git submodule update. So this is very common. I was going to say, this is very common if you're changing branches and your submodules change. They're weird, and people have this problem all the time on CircuitPython pull requests. What will happen is when they make the pull request, they'll switch the state of the submodules, and that's incorrect. And this is why, I think, is that I just switched branches. I switched from a newer branch that had a new version of a submodule to an older branch that has an older version, and it doesn't automatically switch the submodules. Like the regular files switch, but the submodules don't. So this is what will happen is you'll see this submodule, which is the request thing, has new commits, which is kind of lying to you because it's missing. It's just saying like the commit that it's checked out at is different than it was, or different than it should be. Oops, sorry. So what you have to do is you have to do this submodule update. And now you'll see that my prompt went from red to green. And if we do git status again, which those of you who have watched my stream, you should always do git status. That's the first thing I suggest new folks to get, is just get git status as a, like, do one thing, do git status, do another thing, do git status, to be aware of where you are. So let's see if I have it pushed. Let's push it if I don't, because then we'll look at the diff. Since I restarted, I have to get my SSH key. So here's a git interlude. So this is what happened, is that my TLS debugging branch, I have been rebasing, meaning that rebase is like pretend to redo the commits on top of a new commit. And what git checks by default is that when you push to a branch, it only adds new commits, meaning that the current commit is already kind of in the history. But if you push something in the rebase, that's no longer true. So there's this cool flag for git push called force-with-lease. And I actually learned this because somebody talked about, they did an alias for git please. So it's like a combination of push lease and whatever. Hugo points out a post-checkout git hook might be a good to deal with submodules. That's true. I hadn't thought about that. I'm not like, I know parts of Git well. I know the parts of Git that I use all the time well, but I don't know like the things that I don't use. So what force-with-lease is doing is, force is the big hammer. The big hammer that's saying like, I don't care what happened, push it. So this is like updating a remote Git repository. And in this case, it's like GitHub's version. But what force-with-lease says is that I've pulled down the state of that repository, and I think I know where it's at. Force-with-lease says, I'm going to force change it as long as what it is still what I thought it was, like what I thought it was locally. And what that's meant to do is like, if two people are working on the same thing and you force it, like if they've changed it already, like in the interim, it'll prevent that. So it's a good habit instead of do force-with-lease. I never run into it because I'm the only one working on these branches, but I think it's a good policy anyway. Okay, so this is where I've left off in the debugging stuff. Let's pull up my copy of CircuitPython. So it's even nice that GitHub says like, oh, you just pushed here. Do you want to compare? And we can compare in pull request, although we won't pull request. Oh, that's probably a bad idea as well. Compare in pull request, because I actually made my fork before CircuitPython was a thing. Like this is where it started. The diff didn't actually work. Hi, Unexpected Maker. Dropping in to say hi. Okay, so I'm gonna do it against Adafruit, CircuitPython, and then it gets really unhappy because our repo's giant. So it's a slow process. And in fact, our repo is so complicated it really hates us. So one thing you could do is like it defaulted to the master branch in there, but we actually moved from master to main. So what needs to do is we need to switch that to main. Thanks, Unexpected Maker. Have a good weekend too. I guess that you're already in your weekend. I hope it's going well. I'm excited for a weekend, I'll tell you that much. But my weekend's very close. Okay, so this has a few changes in it that are old as well. But let's just take a look at what I have. So this root certificate stuff I think is merged in, so I don't know why it's showing here, but it might be that, oh, you know, I think the reason it's showing is that like I actually, all those little I'm going out of order, but this is basically talking about this list of things that I changed. So all these small changes that I had come out were part of this branch originally, and then what I did is I made a new branch based on that, and then I like deleted all the stuff that I didn't want to have in the pull request. So this old branch hasn't been updated to like not have the stuff that's been checked in since then. So we might see some things that are actually checked in. And let's just dovetail it into here. Nice. I just have to remember to hit the button when it starts. So one thing we did is we switched the root certificates from the default ESP IDF thing to the Nina firmware. One thing I was experimenting with is enabling assertions and having them printed out. So I was using the mag tag to do it. So these are configs that we could theoretically like put in the defaults, but for now, like they're just in the board that I'm testing with. And then the other thing I turned on was this free RTOS trace facility. Basically, my approach to figuring out these hang issues was trying to get the hangs that I was seeing were not like complete hangs. What they were is that CircuitPython was hung. So like if you typed in the serial output, nothing was happening. Like it wouldn't echo back to you. But like if you use the disk drive still works. And so that indicated to me that like it's not completely hosed. What it is it's like half hosed. So like CircuitPython is hosed and it's in a task, but like the USB stuff is still working. So the approach that I was working on was to we have this callback that we use for TinyUSB to get notified when a Control-C happens earlier than we process other characters. So that's a way for us to like immediately get notified when it gets sent. And so my approach at the time was to hook, and we'll see this further down, I think, hook into the Control-C handling and try to print out as much state info as I could. Because what would happen is that like, yeah, I would see it hung, but USB would still be active. And so basically whenever I Control-C, I could print out this, like any sort of state that I want. Which is kind of like very, like, I don't want to have to figure out how to do GDB because GDB could do that as well. But I'm like on a different device that doesn't have easy access to all the JTAG lines. And I'm very much a printf debugger. So my hope was like, it's usually when figuring out a hang, it's a mix of like trying to figure out where things are by just printing out. And then there's also, like this circum way of like, okay, like I'm going to Control-C and it's going to print out the state. So what I was doing here and what I'm doing here, and we'll see it below more, is like trying to figure out these free RTOS states. So what is the RTOS that's under CircuitPython doing? Specifically, probably, why isn't the CircuitPython task running? And it could be something like we're sleeping with a timeout, but that sleeping is like we accidentally did our math wrong. So we're like trying to like sleep for way longer than we intended. That's one thing that can happen. Maybe a dumb question. What's an RTOS? Yes, real-time operating system, I think. DCD asks, any idea why the Twitch bot is 30 minutes late? It's always 30 minutes late. It could have to do with like if it's a cron job that runs once an hour sort of thing. But yeah, I'm not sure. It'd be curious to see if your stream doesn't start on the hour, whether it's still 30 minutes late. Yeah, so RTOS is a term for real-time operating system, which you could think of the operating system part as like you're running multiple programs and the operating system is managing both how to share resources like the CPU and memory, but it's also managing like how to communicate between one program and another. So you'll get like very basic primitives like a mutex and a semaphore, things like that. The RTOS part of it, the RT, the real-time part is you may have certain, I said programs, but like they're also in the free RTOS world, they're known as tasks. So the free RTOS is deciding what task to run. And the real-time bit is that those tasks may be time sensitive. So there's a real-time operating system has mechanics for you to say, like, I need this to run every 100 milliseconds, or I need this to run at such and such. So, and those are not guarantees that a regular, like, Linux operating system can actually give you. So if you ever have looked at our forums and people are like, I can't, like, I'm using Blinka and I can't get the temperature from a DHT sensor on my Raspberry Pi, that's because, like, there's this layer of Linux that is just not real time. Like, there's so much going on, and like, getting into this network stuff is, like, exactly why. Like, it's at any point, like, you may not be able to do something when you need to, and that's going to make, like, time sensitive things unreliable. So yeah, that's the difference between, like, a real-time operating system and a regular operating system. It's also why I'm very interested in putting CircuitPython on the Raspberry Pi, because if we put CircuitPython bare metal, meaning without an operating system, we could actually potentially be much more real time than we can by running Blinka on top of Linux. Of course, the trade-off there is you don't get everything for free. You don't get all the functionality of Linux for free. So there's certainly a trade-off, but I think it's an interesting space to explore. Hi, Alvaro. Okay, Red Yellow says, is it possible to use the UF2 bootloader on the NRF52840 with CircuitPython and Arduino payloads? Yes, you should be able to have the UF2 bootloader installed and use CircuitPython or Arduino. It should allow for both. If you have an issue, then you can get into more specifics, but yeah, you should be able to. Okay, so here's my debugging branch. So here you can see I did some debug prints. Chloe's back. This is one thing that's been merged in. One of the things I thought may be hanging was that networking is complicated because you're interfacing with another computer, and you never know whether that computer is going to actually tell you that, like, oh, like, I'm not going to talk to you anymore. So there's this problem where, like, you could think that the other computer at the other end is going to reply to you, but they're not, and they haven't told you that. So what you end up having is, like, all these timeouts saying, like, I'm going to just wait for you for 2 minutes, and then if it doesn't happen, I'm just going to assume that you've pieced out and aren't going to talk to me. So one thing I was thinking is that the hang could be that we're trying to listen. We're listening for something from this other computer that we're connected to, but it's, like, off in the weeds or something. And what originally we had for the underlying socket, the socket is the kind of abstraction for, like, here's the thing, here's the way that I'm talking to the other computer. And so what I did here in this change that has been merged in separately is just say, like, give us for the socket, give it 2 minutes. And if we don't hear it in 2 minutes, like, just consider it closed. So that's been merged in. That's really a backup, though, because we try not to even we don't try to read from the socket until we think there's something to read. But there's always these cases where, like, maybe we thought we could read from it and we can't. So yeah, this is just a backstop for that. You can see I have some logging for sending and receiving. These are here basically to figure out, like, this is the last thing that happened before I, like, stopped. Like, as far as I can tell, nothing is going anymore. I removed this broken pipe error because basically, like, I wanted to just rely on how much has been received. So if something bad happened, the status is less than 0. Instead of raising an exception that then the higher code has to raise, like, I just return the amount of data that I received, and it might be 0, and that's a case that the higher level code already has to handle, because that's that can happen even when the status is not under 0. So here I have more prints, this time in socket pool. And you can see here that I like kind of fence posted this function call. So like get host by name, and then I just say like host by name is done. That's a way to just say like, am I in here? Doing a similar thing for radio. You can see that I've like added a bit more debugging about like why we produce this radio error unknown, which is something that some folks were seeing. I don't know if ToddBot's watching, but ToddBot had this of like, I can't connect to the Wi-Fi and it's just telling me unknown reason. So this is there to basically say like, if in any of my debugging I see that problem, this will tell me actually more detail. Just switch to some debugging to not do the early logging, but I actually figured out why the early logging wasn't showing up. Basically, there's a difference between the regular logging and the early logging, in that the early logging like will get transmitted right when you do it, whereas the regular logging might actually be buffered, meaning like it'll queue it up, but it might not actually send it out. And you can see I guarded this init, I guarded the dinit. Panic silent. Yeah, so this is me saying like for opt builds, let's have the assertion silent, but then by default, well, here's the Nina stuff again. I thought I turned it on for debug builds. So this is the thing that fixes the early. ToddBot says, yep, I still get the unknown failure problem. I only really get it when I try to join a network that is too far away. Yeah, so this log here would be interesting to see, like, not that one. Well, retry and connect is interesting too. But basically this is, we try for 5 times, but we only try 5 times if it's one of these reasons that the Wi-Fi was disconnected. Nina firmware. So if you go to Adafruit, github/Adafruit/Nina-FW, this is the ESP firmware that runs on the regular ESP32. Amber says, I suggest short tutorial-like videos. Maybe I'm interested on Python to C bindings. Yeah, unfortunately, short videos require a lot more preparation than long ones do. I have covered how to do these bindings before, but you can also just go to this learn guide. So it's written, and it's a bit out of date, but it's not like completely out of date. So if you want something that's concise about the Python to C bindings, like this is a good resource. And DCD, you need a link as well. ToddBot says, quote, I apologize for such a long letter. I didn't have time to write a short one. Yep. Yeah, that's basically it. Like, I do this stream, I do 2 hours, I answer questions, and then I post. Like, it gets posted immediately. But at least I'm putting time codes in. Yeah, it's already like one of those things where it's not really what I get paid to do. Like, I get paid to write software. I don't get paid to stream. So it's like, I can't spend all week producing a small... I can't spend all week producing a short, concise video. But you could go in the Discord and get help there from folks. Dave's going to nip downstairs to make a coffee. Enjoy your coffee. I don't drink coffee. So yeah, talking about ToddBot, if it's a common occurrence that you're seeing and you suspect that we're not doing like 5 retries to connect, it's possible that we're getting a reason that is not in this list. So we could add it to this list, and we still might propagate this reason upwards, but we'll at least try 5 times before we do that, if it's in this list. If it's not in this list, we'll stop immediately. So like there's totally like lots of tuning stuff that we still have to do, and that's just an example. Nick says, the name of the show plus that snake is not a good look. Am I missing something? Deep dive? I think it's okay. Let me know on Discord if there's something I should think about. Yeah, I don't even think I added the BSS ID and channel stuff to Connect. I think Benny also made Connect's changed it. Connect works differently now. It will do a full scan and then connect to the strongest access point rather than the first one, which is what it did before. It's actually, connecting is kind of slow. So that, like, if you want to be quick, you should provide, like, a channel for it. Okay, DCD doesn't see the problem either. Okay, so this is what fixes the log early. So here's what I was playing around with. There's this code within the IDF to print a backtrace. And it's basically giving us program counters and stack pointers. And I was hoping to figure out how to do that for every free RTOS task. So basically, when you crash like really hard, like it'll give you a backtrace. But that and that's really handy because that can tell you where you were when it happened. But in this case of like my USB is running fine, and from my USB code I can have it print things. But when I print the backtrace from there, it's like exactly where I know where it is. So really, what I want to be able to print the backtrace for all the tasks that are running, so I can see like where they all ended up, or where they are currently. So I was just experimenting, and hopefully Benny's still awake, but this is where I would pick up if I were to take the I2C stuff on is, well, first I would get the I2C stuff going and see if anything leaps out at me. But basically here's the CDC RX wanted CB. So this is what gets called when you do a control C. So if I don't know if this is true for the I2C one, but like if the USB is still alive, like the idea is to print out the state of all the other tasks. So there is a way to get the status of all the other tasks, but it's not like super helpful. And so this is like me just starting to understand like free RTOS task stuff. And then I'm also printing the backtrace, but the backtrace is not interesting. Hi, Tabletronics. Benny says, my current state of issue is that after the software load, it scans the channels, but hangs after 3 to 5 with no more output. Interesting. So it's hanging on the connect. Yeah. I don't know. I was thinking I was actually going to take that problem on this week, but it's also been really high priority for me to do the deep sleep stuff. Oh, it's before connect because it's just scanning channels. Yeah, weird. I don't know. I might end up doing it next week. We'll see. I've got some sleep. Actually, that's probably not true, because the work. So I basically let's move on. I think we can move on. So let's talk sleep. So sleep is the process for saving power. So sleep is this idea that I think we've talked about this before. We talked about sleep like a month or more ago now, because I started the work and then I got distracted by network reliability, and then Dan picked up the work. And so the current status is that Dan merged in his PR that was based on my work on Microdev's work. So you can try sleep in the current builds of CircuitPython. There are 2 levels of sleep. I'll just recap this because we did talk about this before, I think. There's light sleep and there's deep sleep. And the difference between the two is that light sleep preserves the state of the CPU and the RAM, which means your code can pick up where it left off. And also, it means that you can, I wanted to like allow you to connect USB and stuff. So if USB is alive, you're connected to it, light sleep will work. That's from the CircuitPython side. Light sleep in terms of the ESP actually breaks USB, so you can't actually do light sleep with USB connected. But there's another level of sleep that's like idle that we do. But from the CircuitPython side, you can either light sleep, which is you're in the middle of your code, you want to like leave all the current state, and you want all the things active to stay active. Then you can do light sleep, and it will do it's like a function call, so it'll return to you the reason that you woke up. And then deep sleep is the like, I'm going to be done with what I'm doing. I just want to run the bare minimum on the chip and everything else can be turned off. And that means that your power gets a lot lower. So deep sleep is actually more interesting for like cases where you want like on the mag tag, for example, which I have on the overhead, which may or may not be, which it is frozen. You can see it in the bottom there. And I have so much trouble with all these cameras. But yeah, so the device on here, it's an e-ink screen, and the idea is that what you can do is you can refresh it every hour, once an hour, and then deep sleep for the rest of the time, or once a day and deep sleep for the rest of the time. And that allows you to save a lot of battery. And deep sleep is important because like it's what you're doing most of the time. So the lower you can get that value, the longer you can live on a single battery. So Dan's stuff was merged in, but I had some nitpicks about how it was done under the hood. What I wanted to see was the code exit, and then the deep sleep happened. But the way that Dan did it in this PR is that when you call exit and deep sleep, which is the function call, it actually deep sleeps before it like cleans everything up. Remember, when you deep sleep for real, like everything gets shut down, so you don't have to necessarily reset things. But the problem is that if you're on USB, or the complexity is that if you're on USB, so you're like editing your code that's doing deep sleeps, we don't actually want a deep sleep. And the reason that is that if we deep sleep, you lose your USB connection. So what I really wanted is this idea that you can iterate on your deep sleep code, and from the code's perspective, it works identically to how it would if it were actually deep sleeping. But it doesn't actually deep sleep so that like all your USB stuff stays alive. And how Dan did that was like kind of weird as well. And so what I wanted to do and what I was working on is tweaking how that all happens. Yeah. So DCD says, did we get a reason code from Deep Sleep Startup? Yeah, so yeah, why don't we just go over this? It's not actually 78 files, but we can just cover it. Dan likes to fix my grammar. I put ITS everywhere, and it's short for it is, so it really should be IT''s. So the way that it works is there's a deep sleep request. It's a show for worker for Hacker Squad. Hi, Headscope. So this works the same way sys.exit works, is that it raises an exception. So you can actually catch it and prevent it from happening. You shouldn't, but you can. And so we now have a deep sleep request exception. So this basically, this is how we stop everything. And then we'll see later that we can change what we do with it. So this is some cleanup, our alarm reset, adding some static things. So Dan has this like, if the return code is deep sleep, then enter deep sleep. Which I don't know. Right. I don't think that does anything. Hi, Emmett. So we do actually have what I really want to talk about. And the thing that I like to review is actually shared bindings. Because shared bindings, and this goes back to Amber's question about like the Python to C boundary. So shared bindings is the layer that does the conversion from Python to C. So we're adding a new alarm module that manages alarms are the thing that wake you up from sleep. So that's why we have this new alarm module. So if you're looking to see what platforms or what boards we support sleep on, you want to look on the downloads page to see if they have the alarm module. So this covers the sleep stuff that I just talked about. So alarm.wakeAlarm is how you get the alarm or an equivalent that woke you up from a deep sleep. Right now, that's going to be a time alarm, because even though we have pin alarm APIs here, we don't actually have it implemented yet, which is what I'm going to do next week, most likely. So that's how you can get the alarm that woke you up from a deep sleep. And here's the light sleep. So you give it any number of alarms, and it returns you the alarm that it woke up from, because you can continue. Exit and deep sleep until alarms is the call. You give it a bunch of alarms. It doesn't return anything, and in fact, it raises an exception. It raises the like deep sleep exception. And there's like alarm.time and alarm.pin. And so that's where we'll add additional alarms, is like submodules. So pin alarm, time alarm. The thing I actually wanted to point out was that we also added reset reason. So not only do we have this alarm stuff, but we also added 2 additional like, hey, why am I running sorts of things. So reset reason, so microcontroller dot get reset reason, I think is what it is. Or no, it's a property. Microcontroller dot CPU dot reset reason, I think. Will return to you why the microcontroller started. So that is one of these values here. So power on. So this is like you plugged it in. Brownout software. So this is like something said like, hey, restart me. Deep sleep alarm. So this is if you woke up from a deep sleep. Reset pin, meaning it's like somebody pressed the reset pin. Watchdog, which is like an external thing that's making sure that things are okay. And then unknown. So we now have the option with this PR to get why did I start up? So why did the microcontroller start up? And then we also added to supervisor the ability to say, hey, why did this run of CircuitPython run? And so it can tell you, where is it? I don't know where they are. Supervisor. Supervisor run reason. I went right by it. So there's startup, meaning it's like the very first time that CircuitPython was started on the microcontroller. There's auto reload, which is if the file system changed and we automatically stopped you and restarted you. REPL reload is like you went in the REPL and you did Control D, and then supervisor reload is if you called supervisor.reload. So we now have like much more information about like why are you running, and that's important also internally because we may want to change what's happening based on those things. Yeah, so that's the initial sleep work. It does work, and Lamore was excited to try it to see how how low we can go. Definitely in the weeds. Dive in deep. So what I was really interested in is, actually I should Control-Shift-T to get it back. So if we look in ports, the thing that I didn't like and I wanted to change was that so this is ports ESP32 common HAL. So this is like implementations of the shared bindings things that are port specific. I didn't like that there was this, actually it wasn't even here. I think it's in shared bindings. Yeah, so in shared bindings in this PR, there's this if workflow active, meaning USB is active, do this wait until alarms thing, and this blocks. Otherwise, there's this light sleep until alarms thing. And there's also this, like, we have this problem that USB takes some time to come up. So if your code.py is really quick, you plug it in, and you could end up getting a deep sleep at the end. We didn't want that. So we have this thing that says, like, for the very first 5 seconds that we're on, I think that's what sleep delay is set to. Like, for the first 5 minutes, like, don't deep sleep, don't do that. So I didn't like that this was in shared bindings. Like, shared bindings should really just be convert the Python world to the C world and then hand it off to the C world. So I was working on that this week, and here's my changes. These aren't my changes. These are my TLS debugging stuff. Then we can close that and close that and close that. This? Yeah, sleep tweaks. So here's the state. I think this is the current state of my work. So you can see here that I've added some temporary logging, which is what I need to delete. But I've also, so where are we? So we're in run code.py. So the way that at the highest level it works is that we have this super loop, which is switching between running code.py, running the REPL. And so to run code.py, it calls run code.py, and then it actually runs it, but then it also stops. So like, if you've seen the like flash the error code sort of thing, like that's this bit of code is what does that. So I added this notion of when it's asleep, and lots of logging, trying to figure out where I'm still seeing hangs. Trying to figure out where it is. But you can see here that so at the start of the loop, I don't know why that's collapsed. So at the start of the loop, we're trying to figure out like, hey, do we want to keep looping? So we run background stuff. We see if a reload was requested, and if we are, we return. We see, oh, is there stuff on the serial? And if it's on the serial, like this is the like type any character to enter the REPL or Control D to reload. So this is saying like, if it's Control D, say we did a REPL reload and return. So that's one way to do it. And then this is saying, oh, if I woke from a sleep, if I woke up from a sleep, like initialize the board again, set the run reason, let us know that this is just a debug on the serial, right? And then we return, so we reload. And this is the pretend sleep that I was talking about. You wouldn't actually get here if you were true deep sleeping, because you would just have entered this function once and run it. So this would be after. Let's see. Then I'm trying to do some display management. So usually with an e-ink, if you exit, will put like, oh, it's done. but we want to prevent that if you tried to deep sleep. So if you deep sleeped and the display, like, we don't want to, oh, I lost my YouTube chat. Oh, and it's back. So that's what this is trying to account for, is that, like, you exited, but you deep sleeped and you want to leave the display alone. Oh yeah, and that's kind of distracting. I should put, actually I could just move it. There. So that's one thing we have to do. So this is, okay, well, we've checked for these other things. We don't want to restart. Let's see if we want to deep sleep. So that's what this return code deep sleep thing is. And now what we have to do is we have to say, hey, like, have we waited that 5 seconds to start up? If we haven't, meaning the delay ticks is greater than 0, like, basically tell the port, like, hey, like, we're going to sleep a little bit later. Like, let us know when this time has passed. And we do that, and then we get down here, and we either... this might be out of date. I think I decided that, like, we would do the animation that we do currently. So it actually, I don't think this interrupt after ticks actually works, because we'll circle around this loop really quickly because we don't have a delay. We only have a delay in the second spot, port idle until interrupt. This is the way that time.sleep works now too, which is why I was like, knowing the way that I would want to do it is because I had done it for time.sleep stuff. So if that's not the case, if we're after the first 5 seconds, if USB is active, if USB is not active, then we actually do a real deep sleep, and that shuts everything down, and we're exiting the loop. We're going to start from the top again. Or if we're not asleep, now's the time that we can start fake deep sleeping. So I'm logging fake deep sleep. I set the status NeoPixel to black, so it's off. And then I de-init the board. So this gives the board to actually a chance to, like, set the pins so that the power to the NeoPixels is off, for example. And it turns out it actually de-inits the display as well. So whereas, like, board init would just run once at the start and that's it, now board init and board de-init will potentially be called multiple times when we have alarm stuff. And then at that point, what has happened is that earlier on, we've set up the alarms already. And so we just, like, okay, we're sleeping. Now we can idle it until interrupt, because the alarms will cause this to return. So we'll idle until things happen. Corolla says, would you recommend using Python for any kind of project, or are there cases where you'd use another language? I think generally I would start with Python. Python, I was just having a conversation with somebody about this, actually. Python is really fast to experiment with. And so if it works through your project, it's a great place to start. But what you may find after 3 hours or so, that there's things you just can't do with Python because it might be too slow. Like, Python's really fast to iterate, and that's more valuable, in my opinion, than actual performance. Yeah, it can be really slow. But it's very fast to write and iterate on, which ultimately is actually what, in my opinion, costs more. Like, time costs more than buying a microcontroller that's slightly faster. Are there cases where you'd use another language? Yeah, sure. I mean, I do mostly C development underneath the hood of CircuitPython. So my CircuitPython bias is that, like, oh, try CircuitPython, get as far as you can, and then when you need speed, add a C module that can do it in C for you. Like, that's a good option in my opinion. But so many languages and systems have, like, all of these things that you have to set up just to get started, and, like, you could spend that time seeing if Python's good for you instead. Corolla says, do you know any hardware description languages? I've looked at I did Verilog in college. I've looked at the Python versions of things. So NMeGen, LiteX, MeGen. And I think that's where I would go if I went back there. I have ideas on how to make it more Pythonic. But NMeGen's pretty good. Okay. So that's sleep, blah, blah, blah. So board dinit, now this is for the mag tag. Now while the display is busy, we run background tasks. We wait for it to not be busy. I think it might not be busy before it actually is not busy. Because I was running this code earlier, and this is why I wanted to set the overhead up. But I was actually seeing like it not quite finish the refresh. Maybe if I switch to here. Oh, the overhead's frozen, isn't it? Just my luck. I'm going to try to unplug it and replug it in. Which I think worked last time. If I remember right. Last time it was frozen, it worked. I think it did. Should I see if I'm frozen? I'm not frozen. Yay. Okay, so here's the mag tag. And let's just watch that. Let's actually do some stuff, huh? Okay, so I'm gonna hit reset and see if we can't get it going. So this has got code from this branch that I'm talking about. And then the other thing that I want to do, can you see that I wanted to talk about microbits? Nothing significant, but I'm excited. They're V2s. I'm excited. Excited for microbit V2s. We could actually like do stuff with CircuitPython on them. Although they don't have the USB connected, which is like mind-boggling to me. That's all I wanted to say about microbit V2. So I want to do a b.r.b API for it. So hopefully this will work. You might ask yourself, like, how do we know if it's working? Well, I did set up, and I know you can't see this. Source. Joulescope. So let's do desktop overhead. See if we can get this working. So here's the Joulescope UI. And we're seeing, sorry, I'm just trying to get it like as big as I can. I don't know why this is so gigantic. I don't want in or out. DCD says microbit is out of stock in the Adafruit store. I was waiting to place another order, but decided to wait until after the deep dive. Yeah, sorry about that. Okay, so the screen did just update. So I think I've got this on. This is 2 minutes worth of time. I don't know how to change. So now what we've done is we've just dropped down. So this is the deep sleep. This app is the Joulescope app. And I would love to make these numbers smaller, but I don't know how. I could turn them off. What does single value do? Yeah, I don't know how to use this. Close. I don't get why I can't make it smaller. Like it's one of those apps where it's like, we're gonna have everything positionable because we can't decide how people want it. Yeah, so I have this on just a 20-second. So it should be 20 seconds between the deep sleep here and the wake up. Stand further back to make the number smaller. That won't help make the graph bigger, though. Like, can I make them? I mean, it's nice that it's readable. Appearance. Dark. Font. Here we go. Okay. Oh, that's not the preferences. Single value. Font. 20. Okay. There we go. But what do you think this is? Oh, dear. I guess I could put it up there. That's a bit better. Yeah, so what is this showing? This is showing the power. Well, it's the current draw over time. So this is like one wake up cycle. I think this is connect to the network and then do some stuff and then probably parse, update the screen, and then go to sleep. And then you can see here that like, oh, this is happening a long time. Well, I suspect this is the hang part that I was talking about. And the other thing, it also did happen, right? So this is, the refresh is not actually completely finished. It should be black on white, not white on black. Madkey asks, can we use external interrupts to come out of deep sleep? Not quite yet, but it's like next on my list. Like I was tempted to do it in this PR that I want to get out today. And maybe I won't get it out today. It depends on how much I get done on the stream. Good night, Dave. Thanks for hanging out. I do want to add external interrupts. I have to keep very narrow focus to have try to have small pull requests. So the next thing I'm going to work on is actually doing the pin interrupts. It's such a bummer. Like, the question is like, what is it doing? Like, we have this hang problem. And it's been hanging for over 2 minutes now. Oh, you know what? I do have the UART set up. So I should be able to do USB. Problem is that I doubt I can control C it. It's actually not connected to the computer. David G says, is there a way to trigger a library bundle release as the current does not contain the latest release of the magtag library? It should happen automatically every 24 hours. If it's not, then it might be broken. So I can turn that on. And none of the USB popped up. I'm not connected over USB, so I can't control C it. And in fact, I bet Control C would not work in this case. Still 2 hours to wait. I'm like so bummed that it's doing this. All right, let's just hit, I just hit the reset button. And it should, if everything is working, which it may not be, it should connect to my USB. But oh, you know, I already have one CircuitPy drive from the timestamp thing. So how many? So at least now we're getting our UART output. And we only have 2 ACMs, so that I don't think the USB is working from the Feather right now, or from the magtag. And it says, connection error, unknown failure. Oh, and you're frozen again. Your overhead stuff is frozen. You can't see my hand. That's so silly. This is why I want a new computer. I like to imagine that all my USB problems would go away if I knew that they were on like separate buses. But at least I can plug it in and unplug it, and it's okay. Could be worse. Okay, so I got that unknown failure error that I was talking about. And this is actually something that is an interesting thought process. What should we do in terms of sleep and LED blinking when something like this happens? Is a question that I'm not solving right now, or I'm not answering right now, but is interesting to me nonetheless. Like, in its current form, it has correctly shown me that like something bad happened and your code's no longer running. So I think with the e-ink screen, that's good. If we look at, oh, you can't see it. If we look at the power, we can see that we're actually at 43 milliamps. So we're like actually not saving a lot of power. And that's because we're not doing any sort of sleep state right now. So I think another subsequent PR for us to do is like actually change what happens on exceptions so that it saves power. And let's actually just take a peek here as well. So it says reason 203 CB, which is, where do we have the Wi-Fi reason stuff is not in here. So what I'm trying to find is the Wi-Fi reason list. Common hell. Wi-Fi init. So these are the reasons we might try to retry. So let's find where that is, and then we'll look it up. Look up this CB instead. So it's in Wi-Fi types, but if we just do this, we should be able to find it. So it's 203, right? So association fail. And then this actually here is kind of interesting too. Thank you, Patrick. It would just tell me association fail. So if we had USB working, we could actually update this, but I'm just going to hit reset. And maybe somebody can make a PR to add association fail to that list of things that we don't want to be fatal immediately, that we want to retry after this list here. Like we have association expire, we should probably have association fail either. The alternative, and I forget who I was talking to about this, but the reason that we have a specific list here is that we want to be able to disconnect the Wi-Fi. And we have to know what the reason is when we like actually disconnect the Wi-Fi to actually like not try to reconnect. And so maybe that's what we really should do. So the refresh worked just fine. And the output looks good. Let's pull up Joulescope again. So this is where I hit the reset button. But the screen refreshed already, and something like it took a while afterwards to go into deep sleep. It is in deep sleep now, which is good. And then it should take 20 seconds for it to wake up. So when it hits this 100 line, it should wake up. Which it looks like it is, which is awesome. Like deep sleep's working, it's just not as deep as it would be nice. And the fact that it's awake for 50 seconds is kind of a long time. So there's like lots of room for optimization still. But the fact that we have like the API out and it's working is really good. So let's just see if this works again. Or I guess we can, now that we have we can leave the UART stuff running. So the refresh worked. But see, like, how long does it take even after the refresh? Because the refresh should be the thing that... Oh, you know what? I think my code is doing a light sleep. That's why... Yeah, this would be faster. I think my code is actually doing a 20-second light sleep. If I remember right. It's doing a light sleep before it does a deep sleep. So yeah, this wouldn't be as long. But again, my like USB is not working, and I don't actually want to mess with it. do I? I'm kind of curious to see if we can't catch that problem again. So what do people think? I guess we should try to see if I can't get the USB going. It's interesting, this dip here, where it's 30. I'm curious about that. And then, of course, this one doesn't look like it ran the deep sleep. I don't want to mess with it, or do I? And Jacob says do it. Okay. But yeah, if we are actually light sleeping, then this one is actually incorrect. Because we should have light slept for a while. Okay, so the reason that I didn't necessarily want to do the USB stuff is that, oh, and look, it's inverted again. Maybe that must have to do with this one that didn't light sleep. It like did it too quickly. So I think I should be actually like able to. So we're in deep sleep now. I just pulled the power, and so we can see that it's like floating. The problem is that I have two things that control whether I can connect to the USB or not. I have this USB cable here. No, I probably don't need to take any more time codes. I think it'd be clearer for me to pull this. Sorry, no more time codes. I don't have enough USB cables here. Okay, let's wait for this to finish. Hopefully. It's interesting that it's like idling lower. Like this might be like a socket mode. Because I think if CircuitPython is running, it's over the 40 milliamps. So like that's all the JSON parsing, I think. And then it does the screen refresh, which is one of the spikes. And then it should light sleep, which I should remove, even though it doesn't work consistently, which is weird. And the light sleep is 20 seconds as well, I think. I wanted to make sure that they both worked. Yeah, so now we're in deep sleep. So I'm going to unplug it and try a different USB cable. So the way I have a custom faceplate on my Joulescope that I made. Come on, USB. All right, I did get USB. That cable is, this cable is unhappy. So here's the code. Yeah, we can reload it. Right, because the other code up I had was different. So let's see, do I have any secrets in here? I don't think I do. Here's the code that's running. It's doing all of the update for the clock and the weather icon. So it's doing one fetch in this update weather from the weather URL, which is the Open Weather API. And then in our loop, we're doing update weather. We're doing, this is actually meant to be a clock, but I've clipped its wings, so it only runs once. But here you can see that we have a light sleep that's happening, and I just want to stop that from happening. So I'm gonna just hit save and let's take a look here actually, because not that. Now that we're on USB, like we're not light sleeping. We're not deep sleeping at all. We're doing fake deep sleep. So if we look at what do we think? This is my keyboard. I've like messed up my keyboard connecting to, because my keyboard has a thing as well. Okay, so let's see, where are we? We should be able to Control C. All right, so we were in the middle of updating. And so now we're idling, and we're idling at like 46 milliamps. So this is just CircuitPython running in circles, which went on USB. So we could probably make that lower. It's not a huge deal. You have a power supply. But let's Control D and watch what it tells us. Move this up here. Skylab's my access point. Spoon says, looks awesome. I was interested in this specifically for the MagTag with a conductive moisture sensor. Yeah, I'm liking the MagTag a lot. All the sleep stuff is new, but I'm very excited to get, like, it's something people ask kind of from the beginning. And for the first couple of years, we're like, no, we're not doing that. No, we're not doing that. But now now I have this message that says pretending to deep sleep. So this lets us know that, like, from your code's perspective, we're deep sleeping. I mean, we're idling at like 45 milliamps, which is not spectacular. Which we should be able to do better. Oh, and we crashed. Interesting. Very interesting. So we lost the serial connection. We refreshed the thing. It says code done running. And I suspect we lost USB as well. I mean, it says I have the drive mounted still. Let's look at... This has been my life. Like, just run something. Just run CircuitPython until it crashes and then try to fix it. So this is interesting. This is the startup code. So it looks like we just started up. So this is an RTC software CPU reset. And I was like, I was really thrown off by this. I'm like, I'm not resetting it. I'm not resetting it. And then I had this idea. We reset when we want to go into safe mode. And I just fixed this. So what we should be able to do is, I fixed this in this PR and I'm very excited about it, obviously. So let's do screen again. And now we can see that it didn't tell us the whole message, but we're in safe mode. And safe mode is, yes. Okay. Safe mode is great because, and we use it for some, like, in ARM world, we use it if you, like, divide by 0 and you get a hard fault from the CPU. But we also use it for things like this, which is if you try to raise an exception when the VM is not running, what will happen is you'll try to do an allocation to a heap that doesn't exist. And so what we'll do is we'll safe mode. And this one in particular is a safe mode that, like, most users should not see. It's really for me to be like, hey, like, you're doing something you shouldn't. And so that's a bummer. But it also means that, like, we're in a pretty good spot. Or it took me so long to realize that we didn't have this. And now that I implemented it, Joiko says, what are you using for current measurement graph? I'm using Joulescope. Joule is in the unit of energy. Joulescope. I can actually point my overhead. There's the Joulescope. Oh, that's not the Joulescope. What are you looking at? Where's my hand? Oh, you're looking at microbits. There's the Joulescope back here. So USB comes in here. This red light, this is a custom faceplate of mine. It has a USB switch on it, so you can turn data off and on. And then it comes out here, and that goes to the MagTag here, which I like. Okay, so this is a safe mode crash that I didn't think we had. And we have 25 minutes, so I think we should just figure it out. So let me show you my process. I think my initial reaction to this is like, we should just print a backtrace whenever we're about to reset, and I'll be able to use that to see where reset the safe mode stuff is happening from. So I'm gonna hit the boot button and the reset, and that'll disconnect me, but that'll put me in bootloader mode, which we should be able to see here. So it's waiting for download. In the ESP, I just restarted, so I've got to do the. And this is also interesting actually, because the boot ROM is like 14 or 15 milliamps, so that's kind of like a really interesting baseline as well. IDF I need to do and no export. And then export. Now I should be able to build. And I just want to do... Oh, I'm in the wrong... I got to change branches. I'm in the wrong branch. But I want to snag something from here first. I want to snag the... I want to snag the line to print out the backtrace, which is in USB, this ESP backtrace print. So I'm going to copy that, and then I'm going to check out, what did I call it? Sleep tweaks? Sleep tweaks. Okay. And you'll notice the git submodule is different again. Should have git statused, but that's what it was. Okay, so I got the backtrace. We can reload everything. Sure, why not? And then I'm going to put it in ports. And this is where we do the reset. So there's this reset to bootloader and there's reset CPU. And that's where I want to do the backtrace print. So anytime we call reset CPU, we're going to first print the backtrace for it. And that probably won't compile, but because I probably need an include. But I will try it anyway. And did we decide? It's on ACM1 now. It's funny because like usually the keyboard's 0, but if I sleep with them both connected, it might not actually be the case. All right, so we're building. We added the the backtrace print, and the likelihood that we hit that safe mode again is probably not great. So we may not see it immediately. Nice. Free PR for someone to do. Yep. Yeah, and just like I thought that it would be. It's in like debug helpers. So this will tell me where it's printed. Yeah, it's in debug helpers. So I'll just copy this. And I like to sort it alphabetically, but it's temporary. I mean, maybe it shouldn't be temporary. I feel like maybe we want a way for the port to be notified the safe mode is in progress. Hey, my hand still works, or my overhead still works. So we can watch this as it flashes. So it's building now, but we'll see more activity here when, like, flashing spy flash actually takes a lot of power. So we'll see when that happens. It's a really handy trick for the IMX RT as well. If you monitor the power, you can tell whether like you're actually writing the spy flash or not. See? Erasing flash. 19 milliamps is still not too bad. Now we're writing. I'm actually going to close the window. It's chilling here. Okay, and then I have to hit reset. All right, I'm gonna let you watch this while I go use the bathroom quickly here. I didn't have to pee before, but now I have to pee, so I'll be right back. Okay. Now I'm back. Now I don't have to dance around, even though you can't see me. So where are we at? Did that that safe mode happened? Were we fake deep sleeping or were we not fake deep sleeping? It looks like we're hung, actually. So we're in this, like, we got the IP state, but, like, we're waiting on something. Fake? Yeah, we're in fake deep sleep. Okay, let's connect. Patrick says, you think USB was connected when the crash happened? So, I mean, something is not... we fixed a crash and we got a hang out of it. This is like how I feel like it's going. This is how it's going for me still. It's funny though, because a lot of the problems that we've been seeing, I think, are like they don't happen when the deep sleep basically resets everything. Oh, now you want pets? The cat is rubbing against me. You can't see him here. You can see me. Spook. Kitty. And put him on the chair next to me here. He likes to sit. I can stand at the desk and he can purr and get pets at the same time. Okay, so I think we're in a hang state, which we were talking about earlier. So this is the serial connection. And if I control C, nothing happens. But I think if I had put a print, like this is not the TLS debugging branch, But because like if I pull this up and I connect CircuitPy, like I can list all the devices, I can edit the code, I can hit save, like all the USB is alive, but like CircuitPython itself is not, which is something I've been trying to figure out. But like it just is a GOT IP. This is like going back to the I2C question of like, how do we do that? DC says, I wonder if a second screen can display more information. But that would change the environment we were debugging. What about spitting out trace data out a second UART? Yeah, potentially I could. Like maybe there's a way to just like spew everything that we're doing. That's certainly an option. Like I have this UART here is not dependent on USB, or at least it's done through a UART to USB converter. It's just a matter of like having helpful things in it, like printing out in it. Which is why we added the backtrace thing to the reset. So I think what I'll do is I could add something to the Control-C to show that like you can actually still print. It's just the CircuitPython task that's unhappy. But I think well, yeah, maybe I'll just do that. The problem is I like this is a problem that's not because of the sleep stuff I did. And so, yeah, I just want to reset. I can't do everything at once, unfortunately. It's so frustrating. Like that's a separate issue that I'm not going to address in all-in-one PR. And like this PR has enough improvements, like safe mode, that it's worth trying to get checked in. I'm very much known for doing too much in one pull request, so I'm trying to be really good. Although I'm like moving a header file, and I think I have to update like all the board files. Hi, kitty. Spook's here to help me out. Pretending to deep sleep, and it did manage to wait. Like the screen refresh went okay. So we're in the pretend deep sleep, which is 43 milliamps, which is not spectacular. But now our code's running again. We're doing the Wi-Fi scan. Maybe? It's interesting to see, like, okay, now we're retrieving data. There's not spectacular prints in the code here. Like, at what point do we start parsing the JSON? One thing you can do usually also is, yep, Professor Sparkles. We're doing deep sleep. We're trying to find bugs. We're finding bugs, we're just not fixing them. Been craving that feature. I know. It's going to be so good when it's solid. Like, this is not a sleep problem. This is a network problem. Like, we're in the middle of doing network stuff. DCD says, well, you're not creating new bugs. Well, you don't know that. Some other bugs are new. I mean, theoretically, this should kick out after 2 minutes if it's like in the internal socket stuff. That's the problem. This is why I kind of like having it running while I'm doing other stuff. Because then I can like wait for it to fail. Like I would like to fix, so the safe mode problem, like the thing that kicked us into safe mode, I would love to fix because it shows that like raising an exception outside of the VM happens. Yes, it's Joulescope. Raising an exception outside the VM happens if like logic outside the VM is incorrect. And so I'd like to just like fix it. Like that's the solution really for that safe mode. It's just like it's a programming error on my part or like one of the first people. Yeah, the x-axis is 2 minutes. So I don't think I can, like I can't control C. Like control C does not interrupt CircuitPython. And this is exactly what it hung at last time too. I'm just going to hit it again. Maybe I'll turn off USB. But we thought we hit the safe mode with it on fake deep sleep. Try it again. Because the safe mode problem is something that's probably in my current code. I also want to see if I'm trying to get one of those fancy new Ryzen, and Newegg refreshes at 4 o'clock every day. Let's see what Newegg says. Is Newegg releasing more today? No. Or at least they haven't posted it yet. Yeah. Yep. Okay, so it looks like... I don't know what we're doing. What do you think the code's doing here? Certificate validated. The time is wrong. Fake deep sleep. It is interesting how smooth the power consumption is during fake deep sleep. I mean, it's surprising that it's 42 milliamps. I think that seems kind of problematic. Woke up from fake deep sleep. Board init done. Things are running. That's good. All right, are we gonna hang again? Doesn't look like it. That's further than we got last time. Man, I'm shocked that like that safe mode thing is not reproducible. What happens if you copy a file out of the USB drive in fake deep sleep? Probably would draw more current. Yeah, I think it would draw a little more current for the read, but it shouldn't interrupt it at all. It's only writes that would. So if you write to the drive while you're in fake deep sleep, it'll exit the fake deep sleep, but it won't. It will do a auto reload style start. It won't pretend to have woken up. Although that's interesting, because we should probably turn the board back on. I wonder if that's it. I wonder if that is I mean, I wonder if that's a problem. Let's try that. Okay. So what we're going to do is we're going to save to the file while we're in deep sleep. I suspect that's where our crash is, actually. I don't think I handled that. Okay, we're in fake deep sleep. Quick. Code to pi. We're doing some reads. Let's do some writes. Where's our hello? 1, 2, 3. Save. What did it do? We're in fake deep sleep still. It didn't interrupt it? What are we doing? That's a good thing to test, though. This looks like Wi-Fi. This looks like... I mean, this looks like Wi-Fi for sure. Stop. What are we doing? We're doing something. What exactly are we waiting for? We're waiting for it to not work. Oh, none type has no attribute show. This could be a sync issue. Yeah, we earlier we've what? None type has no attribute show. Did I break it? It's not happy. Line 17. Oh, you know, this error might be because we haven't initialized the display. Like we haven't re-initialized. This is the thing I said would probably lead to a bug. Yeah. Professor Sparkle says, oh, okay, one of those sporadic, hard to reproduce bugs. And Jacob replied, a few of them, yeah. Exactly. Exactly. So this is, I think, is the case that I was talking about of like, if we're exiting deep sleep, but not as an exit. So that is, if we go to main, this is the last thing I'll do, and then I gotta get out of here. So if you have any urgent questions, ask them now. But in main, we have to say, oh, you can't see this. Here's main. Actually, let me blip that because I'm going to fix it. So run code.py. We need to see if reload requested, if asleep, then we need to board init. And we need to do that here. And we also need to do it here. And I think that's all. I need semicolons. Let's see. We say we woke up. We do board init and we set the run reason. We don't want to set the run reason because that's part of the pretend. But we do want to make sure the board is initialized again. So let's do that. Programming is all about corner cases. And let's flash it again. Last flash of the day. We can watch it here. We can watch it on the power meter. I can secretly check Newegg. I don't think they're releasing anymore. DCD says, you can say that again. Corner cases and error handling. Yeah, error handling. Like, networking is all about error handling, and it's like, makes me unhappy. I want to go back to a disconnected world. Just like, networking is all, like, at any time you could get an error. And not even, like, an obvious one. Like, timeouts and stuff are not easy. Okay, so we're flashing. Interesting. We didn't see the giant spike, did we? Oh, we're just like relative to stuff. All right. USB come up. So we'll watch these two. I don't even remember what I just fixed. Oh, I fixed the board display while deep sleep. If I do a reload. So I'm going to want to, while it's faking deep sleep, if we get there, I'm going to do hello 456 and save it if we ever get there. Or we might just hang. Or not. Yeah, the vertical scale on the Joulescope does change. It's like auto ranging. I've not used it that much, so there's probably a better way to do it. Retire failed. Where are we here? So we did a second SSL connection. And now we're just waiting. Like, I assume the spikes are Wi-Fi stuff, so like something is happening. Is it hanging on the JSON parsing? It's possible. I don't have a lot of debug info about what it's doing. Oh, something changed. Parse time 3 seconds. Okay, so we're pretending to deep sleep. So it did work. It just took a while. Oh, and I've got to mount it. Sorry, I'm rushing. Save. Okay, pretending to deep sleep, soft reboot. And we're running again. But the board should be initialized. And so it should all just work. Yeah, so I think we at least fixed that bug. We now will re-initialize the display when we exit early from a pretend deep sleep, which is good. I'm sure there are other bugs. We know there are other bugs. But we have the debugging for the printing the backtrace. We could just leave that in. Like, I could even check that in. That's fine. But yeah, this has been my life for the last 2 weeks of just like, do I need to create an issue so you can mark it as fixed? No, I can't, because like it's a bug that is in code that's not checked in. So it doesn't need an issue. But good thinking. There's plenty of issues we can mark as fixed, or we can fix. Anyway, let's wrap up. I'm going to get out of here. Go for a walk. Thank you all so much for hanging out with me. This has been another deep dive with Scott. I'm Scott. I go by Tan Newt online as well. I'm paid by Adafruit to work on CircuitPython full time. It's all open source. So if you want to support me and support them, you can go to adafruit.com. Purchase really cool hardware like the MagTag here. That'll just keep working better and better as we work on it. It was early days and now it's like middays. It's still not like super stable, but we're working on it. That's the benefit of supporting Adafruit, is that they support their hardware and the software that runs on that. So go to adafruit.com, support them. I do these. My GitHub is TANNEWT. I will type it in the chat because somebody asked. I do these almost every Friday at 2 p.m. Pacific time for the 2 hours that I just did. You can also, if I don't do Fridays, I'll usually do Thursdays. Going into the end of December and early January, be sure to take a look in the descriptions and things. I'll let you know what my schedule is around the holidays. You can always find me and a whole lot of other awesome people on Discord. The Adafruit Discord server, which is adafru.it/discord. People are there all week. They're super helpful. I'm there during the week and like to help people as well, particularly if you're doing debugging for things like this. That's the place to be to talk about all of these challenges and these issues that we're trying to hunt down and fix. So if you want to pay attention to how things are going there, that's the place to go. And with that, I'll see you next Friday. That's the plan. I think the week after that will be a Thursday. Yeah, thank you so much. Thanks for hanging in there with me and hanging out with Spook as well. So we'll see you next week, and we'll chat with you on Discord before then. Until then, we'll have a great week and weekend. Bye. I pet the cat, but you can't see him. He's not in the picture. He's cleaning himself on the cat tree. All right. Have a good night.